Now we can do it. Hope you don't mind me taking the time to video because you can go back and, yeah, it's writing now. Okay, good. All right, good. So number 4, and we're on page, oh shoot, 93. All right. It says the position of a squirrel, there's old Shirley Squirrely, running in a park is given by, and so we write the function. So we got a squirrel here. And, oh Lord, I can't draw a squirrel. And there he is. There's his tail. He's running in the park. Let's just say he's running that way. And his position is equal to R. That's 0.280 meters per second, T, plus, that's a T, by the way, 0.0360 meters per second squared, T squared. And that's all I, caret cap. Plus, I'm going to run out of room, 0.0190 meters per second cubed, T cubed J. Okay? So here's my X component and here's my Y component. You should be able to determine that just by looking at it. What are Vxt and Vyt and the X and Y components of the velocity of the squirrel as a function of time? All right, well, let's just look at it. So 4a, we want to know what the velocity are in the X and Y direction. Okay, everyone see that? Well, let's look at it. The velocity in the X and the Y would be what? Well, make sure I wrote everything down correctly. What do we got to do first? Notice this is R. R is what? R, displacement. Yeah, displacement. So what have I got to do to find the velocity?
Take the derivative.
Very good. So the velocity with respect to time in the X direction, we'll take the first order derivative. So this is going to be what? Now this is all I, right? This is all my X, correct? So it's going to be what? 0.280 meters per second plus what? Well, if I multiply 2, now watch what I'm fixing to do. We know we do what? We multiply this by 2 or put a 2 out front. We can do it either way. You can put this and put a 2 out front, or just go ahead and multiply it through. Then it's going to become what? 0.072. And to make sure I haven't left any variables off, yeah. Meters per second what? Meters per second squared. Because my units don't change. And then we have to do what, don't we? We have to leave it T, don't we? You say, well, now that's second squared, that's accelerated. When I multiply this times time, the squared goes to seconds. So don't freak out now. Okay? So that would be the what? That would be the X component, and then the Y component, which is this right here, is going to be what? So we got velocity in the Y with respect to time. Well, we take the first order derivative. So 3 times 0.0190 is going to be what? It's going to be, let me make sure I give you the right answer here. Yeah. So we multiply 3 times that value, and we get this number. We get 0.057. How'd I get that? I multiplied 3 times that, okay? Meters per second cubed. and put that in parentheses, t squared, because remember your derivative, you subtract, right? We can do a derivative, but we can't add and subtract. Isn't that what Mr. Leith always used to say? Okay, and so here's my x component and here's my y component of velocity, right? So it says find the x and y components of velocity and the what? Of the squirrel and the x and y components. Okay. So your x and y components are going to be here. Here's x. This is x, and this is y. That's y. And then here's your velocity x and y. Any questions? See how easy that is? That's not hard. Just, again, guys, listen to the question. Do not overthink it. I'm telling you, one of the worst things I used to do was overthink these stinking physics problems. I just think them to death. Quit doing that. Don't do that. Listen to what the question asks, look at what you have, and go. Don't overthink it. All right, part B. All right, I'm going to erase this. Hopefully everyone's written it. I'm going to start over. So this is 4B. 4B at time, and then it says at time 5 seconds, how far is the squirrel from its initial position? So at time 5 seconds, we want to know what? We want to know it's how far from its initial position. Oh, so is that, what is that asking for? In other words, it's wanting to know its distance, isn't it? How far is it from its initial position? It did not say what are the x and y components. It says how far. Here's another hint. That is magnitude. How far is it from its initial position? It did not say anything about x and y, I, and j. So ding ding, what is that telling you? That you're probably going to end up doing what? Man, who's singing? Woo, turn your mic off, please. Hello? There we go. Turn the mic off, please. There we go. Thank you. All right. I didn't know I'd start making people sing. All right. So when it's asking for distance, how far it is, that's magnitude. So we're going to end up doing square root of squares. But first of all, we've got to find what? Well, we've got to find the actual displacement, don't we? Yes, we do. Well, all right, we'll plug it in, guys. We had the function. We had r with respect to time. The time is 5 seconds, so plug everything in. So we had what? We had 0.280 meters per second times 5 seconds plus 0.0360 meters per second squared times what? 5 seconds squared. And that's the caret cap, that's the x component, plus 0.0190 meters per second cubed. And then we do what? We say 5 seconds cubed, don't we? Okay? So what is our Rx going to be? Our X part is going to be, when you do all this arithmetic right here for the I component, is going to be 2.3 meters. And the Y component is going to be 2.38. 2.38 meters. But that's not what it asked. This is x and y. It says how far. That's distance, that's magnitude. So we got to take the what? And if you want to put the capital R, which means the resultant or the magnitude, then we do what? We do 2.3 squared plus 2.38 squared, and we get R, or distance, being what? 3.31 meters, right? Okay? Everyone agree? See how easy that was? Now again, you say, well, how'd you know that? How'd you know? It said how far. It did not say x and y. It did not say unit vector notation. It did not say components. What are the components of the squirrel's displacement? It didn't say that. Had it said that, then you would have left it right here. You would have said 2.3x and 2.38y, or 2.3i and 2.38j. But it didn't say that. Okay? All right. And now let's look at C. Any questions? I hope this is helping. All right, what does C say? At time 5 seconds, what is the magnitude and direction of the squirrel's velocity? Well, ding, 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 ding. Did you hear that? What is the magnitude and the direction of the squirrel's velocity? Notice it said magnitude. Y'all, that's a dead giveaway. Now, far, I can see where you might be a little confused because it didn't say magnitude. Well, far and magnitude, same thing. Far is distance. Distance is magnitude. Displacement has magnitude and direction. Distance only has direction, magnitude. Okay? All right, so we take the first order derivative, which we've already done. Doggone it, I wished I'd written it down. Okay. So we take the first order derivative, and we got to plug in at C, and we got to find the velocity at time 5 seconds. So we take the first order derivative, and I do have it written down, I think. Yeah, it's the velocity is equal to, in the x, and I'll just do it this way, is 0.280 meters per second plus 0.072 meters per second squared times 5 seconds plus, and now this is caret cap, let me do this, that's the I component, the x component, plus, let me erase that right there, there we go. The y is 0.057 meters per second cubed times 5 seconds squared. This is the j component, okay? That's the y component. So what you should get then for the x part, the x, the Vx, see here's your x, there's your y. Vx is going to be 0.64. And Vy is going to be, where's it at? 1.43. Now how'd I get that? Well, come on guys, work it out. Multiply the 5 through, square the 5, multiply it through, then you'll have, and then you add these up, and you'll have, it'll actually look like this, 0.64 meters per second I plus 1.43 meters per second J, if you wanted to write it that way. But you don't have to, unless it asks you to write it that way. Now we got to find what? It said the magnitude and the direction, so that's going to be the square root of the squares, so we got to come in here and do this right here. Plus, and you don't have to put the units if you don't want to when you do the square root of the squares. I won't count off. And so the magnitude of the velocity is going to be 1.57 meters per second. There's the magnitude. Now, someone tell me, how do I find the direction? How do I find the direction, somebody? Do arctangent? Well, I guess so, Mr. Shields. Nobody's saying anything. So we have what? We have arctangent of 1.43 over 0.64 And we get an angle of 65.9 degrees. So how would that look if we drew it on a graph? Well, let's see. It's probably going to be somewhere like that right there. A little bit higher than 45. Okay? Everybody good? Does that help? So there's your direction. And there's your magnitude. Any questions? Oh, that's a really good problem. Okay. All right, we've run out of time. Y'all, what I'm going to do is I'm going to go through here because I know some of you are asking about these even-numbered problems, what the answers are. And I've got a couple of more even-numbered problems, number 6 and number 20. Man, I really wanted to work number 20, but we don't have time. But I'm pretty sure I already have it worked out on video. So if you will go, let me pause this a minute.